So if you see any kind of quantity like kilograms or seconds or degrees or gallons, if you can describe it with one number, it's called a scalar quantity. Now, if you add more descriptors to it, like let's say that you're moving 55 miles per hour. Is that a scalar or a vector? It's a scalar because it's just telling you how fast you're going. But if I'm going 55 miles per hour to Hutchinson, Minnesota, then that's giving me one number, a scalar, plus a direction. And if you add a direction to it or a second descriptor, it's called a vector. So can you accelerate upward? You can accelerate downward easy. But how do you accelerate upward? Jump? No. That would be decelerate if you jumped up. What's that? You'd have to have a lot of force. Can you accelerate upward? Rockets are perfect examples of accelerating upward. So direction makes a difference for acceleration. Force, I can apply force different ways, different directions. That's definitely a vector. Velocity, I can go to the cities, I can go to the country, I can go home. The direction makes a difference. So scalar plus direction is a vector. We usually refer to it as magnitude and what? What was the villain? Magnitude and direction, yeah. In Despicable Me. All right, so let's talk about the anatomy of a vector. When we look at the start of a vector, we call it a tail, and the end of the vector is the head. The head has the arrow to it, so when I draw vector AB, I might make a little line with a little half arrow on it. That shows me that the head is here, and the tail is back here at A. And again, that is the start. Where we start is the tail, and where we end is the head. Okay? You can have different kinds of vectors, but like this one, here's starting at this point, you're ending up at that. And is it the same vector if I go like this? Why not?
Downwards, but it's the same length, but it's going in different directions.
Perfect. Same body, same magnitude, but a different direction. This would be a different vector, this would be a different vector. All these are different vectors. But if I were to take this vector here and move it over here, is it the same vector? Yeah, because it's still pointing in the same direction, same magnitude. So let's talk about magnitude a little bit. That's the body of the vector, and that is going to be the magnitude. So if you want a longer vector, it will have a greater magnitude. A shorter vector will have less magnitude. But the direction is always oriented from where you start to where you end, with the arrows showing that. So if you want to have two equal vectors, you're going to have the same what? Magnitude. Good. Magnitude. By the way, before I forget, magnitude is different than absolute value. For vectors, magnitude are the little bars that look like absolute value. Same magnitude and also the same direction. Those would be equal vectors. Now, to be negative vectors, like, let's do this one here. Whoop, that was interesting. Okay, so if I take this one, I thought I made another one. I guess I didn't. Clone. Clone it. So it won't clone. I'll just draw it. It's not that hard. Okay, so I start here. And this is the opposite of A because it has the same magnitude, but what's different? opposite direction, right? Opposite direction. Now, a zero vector is really fun to draw. Are you ready? There, I drew it. Shall I draw it again? There, I did it. So zero vector has a magnitude of what? Is 0, and what direction is it? All directions, or none. There is no direction to it. So how could a zero vector be even helpful? Or who would even care about a zero if you can't see it or draw it? Well, think of walking in direction A, and then walking in direction negative A. What's interesting about where I end up? Same place. That is the zero vector, the sum of two opposite vectors. So we'll use that one a lot in the future. So here's a little exercise. See if you're paying attention. State which of the vectors shown have the same magnitude and are in the same direction, and so on. So like, for example, I'm going to show you how to write these. Have the same magnitude. Is there anything that has the same magnitude as A? I would say G, yeah. Anything else? I'm wondering about F. I think you're right. It's going to be, I'd say it's a little short. F is a little short. I think this is good. But F is going to be the same magnitude as what? D, yep. How about B? Does B have any same magnitudes? E, yep. Any other ones? There's one more. U, yep. Here you go. So you do the same for questions B, C, D, and E. See which. All right. So if you took same direction, are there any in the same direction as A? C is, yep. And by the way, you wouldn't put magnitudes on there. You just would put A equal to C and nothing else. Any others? How about B? Well, these two are equal to each other in direction. B is equal to what? In direction. E. And I don't think I should write them in that form. I think I should just pair them up like this. And then you said B and E. And then we'd also have D and what else? F. And any others? Is that it? Yeah. How about in the opposite direction? So A is in the opposite direction as G. C is in the opposite direction of what? G. And any others? I think that's it. D, equal vectors. So I don't think A is equal to anything. Is B equal to anything? Yep. We can put equal. And D, equal to what? F. Good. And then the last one for parallel. A is parallel to C is parallel to what else? B is parallel to E. I think that's it. Any other parallels? D and F. Good. All right. So those are equal vectors. Well, now let's get to the good stuff. Now we're going to draw vectors. We're going to add vectors together. Drawing a sum has some steps. A plus B. The steps are kind of easy. First, you should copy the first one. Copy A. So I'm going to copy A here. Move that down there. Okay, now once I have A, I'm going to copy B, but I'm going to copy it so the head of A follows, followed by the tail of B. So in other words, we add these head to tail. So I'm going to copy B, and I'm going to put it right here. Okay? So looking at my ticker toys, this is not the sum of A plus B. It's a lineup of the vectors, but it's not the answer. To get the answer, you have to do step 3, is draw resultant. Okay? From the tail of the first to the head of the last. The head of the last. Alright, so this is not an answer. A plus B is not an answer. What we need to do is we need to draw an actual vector. That isn't an answer. That's wrong as well. You need to put an arrow on your resultant so that that is your answer. So take a moment. Would you draw your resultant? That is not correct unless you put the arrow on it and you write an R. Yeah?
I know where to put the arrow.
Yeah, good question. So I started here, A, and I ended A plus B. I ended at the head of B.
Okay.
You're adding these head to tail, so you're kind of doing, I'm running here and then I'm running there. Start to end is where that resultant is. Okay? So we're going to do a couple of these. I'm going to add A plus B. I'm going to take A, I copy A, and then I'm going to add B. So B starts where A left off, here, and I go over, there's B, and so that, is that my answer? A plus B? Still not there yet? How about that? Is that the answer? Still not there yet. You have to show where you started, which was here, and where you ended is down here. That is your resultant. Notice that I have an arrow and I have a body for that. You try B, H, and F. So you copy A, you go B here, so the result is from the tail of the first to the head of the last. So that's your resultant. Let's do that again. What's that?
Do you need to write down A and B too?
Sure. Yeah, that's just helpful. So you have A plus B, and then you go from the tail of the first to the head of the last. So here's your, put a little half arrow on that one too. And then the last one is going to be A plus B, and so that's going to be tail of the first to the head of the last, and we'll put the little R with that. Seem easy? It's because it is. Super easy. Then the last thing today, we'll look at how you would do this with an actual word problem and tie in some trigonometry. So let's say I have one person who's pulling with a force of 40 newtons northerly, north, and one person that's pulling easterly with 60. So this is 60. This is 60 newtons. A little hard to read there. 60 newtons. And then this one is going to be 40 newtons north. All right. So here's what my question is. If I were to draw a whole bunch of directions here, call this A, B, C, which direction would that safe move with that 40 Newton and 60 Newton? Which direction? H, right? Not, Well, aren't they pulling this way and then pulling up? The two of them together are going to pull it in that direction. Do you see why this is so grotesquely wrong? Because you're saying you're moving that safe in direction B. There's no way that's going to be. The only way this is going to work is if you added the 40 Newton to the 60 Newton, and then when I draw the final one, we go tail of the first to the head of the last. There's what my resultant is. So how are you going to actually find this if this is a 90-degree angle? How are you going to find it? Pythagorean theorem. It's 40 squared plus 60 squared, and what do you get? Think of it this way. It's going to be more than 60, more than 40, but if you added them together, they'd get 100. It's got to be less than 100 and more than 60. What do you get? 72. About right? It's about right? And that makes sense with reality. Together, we're pulling at about 72 newtons in that direction. That's the power of using vectors. You can represent things super well. All right, go down to the homework. And with the homework, you're going to do number 5 here. We're going to add all these. Number 6. And then don't forget this word problem here. This one's a good one. Make you think a little bit. And I'm going to have you work on these for the next 10 minutes. And then we'll actually go over it in 10 minutes. And then you shouldn't have any homework today.